This conference will now be
Hey guys, this is
recorded.
Naveen here. Welcome back to Naveen Automation Labs and welcome back to Data Structure Series. So, in the previous sessions, we have talked about how to implement a stack using array and linked list, the dynamic arrays as well as the static array. Today, we will talk about queues because queues are very important topic for interview point of view, and in almost every company, that will be the first question that okay, after stack or how will you implement queue? So in queue, we have to maintain two counters because whenever you have to enter the data, you have to enter the data from the rear side and then you have to fetch the data. You have to fetch the data from the front side. Now, what is front? What is rear concept? You have to understand that. And queue is always first in, first out basis. So stack is always last in, last out, but queue is always first in, first out. Means whatever the first element is there, right? So the same element should be returned out first. So there are two major operations, guys, you have to perform. So this is a diagram I have taken from one of the website. I really like this particular diagram. Instead of I'm creating a diagram in front of you, so that better we take this particular example. So this is an example of queue. So in queue, let's see, this is a array and having some indexes over here, 0, 1, 2, up to 5. The data is already filled. And you can see that 5000, 5004. So it will take, every section will take around 4 bytes because we are storing integer, and integer will take in Java around, okay, 4 bytes. So the text allocation 504, 508, 12, 16, something like this. So what we have to do that this is my index and this is the two pointers we have to maintain. One is the front pointer and another one is a rear pointer. So front means this is the front of the queue and this is the rear of the queue. So what exactly it will work? How exactly it will work? So whenever you have to insert a data, so let's say I want to insert one more data, 66 over here, right? I want to insert 66 over here. So the data will be inserted at the rear side. Remember this thing, right? So whenever you have to perform the queue, okay, whenever you have to perform the enqueue operation. So this is for enqueue. It means whenever you have to add the data. So adding the data is always rear side, and front means you have to decrease the data over here. So at the front end side over here. Okay. So there are two operations. This plus minus operation is called. This is plus is called what? enqueue. enqueue means add the data, okay, in the queue. So this is called, this operation is called enqueue. Remember this thing. This is, I'll say enqueue, and this is called dequeue. Okay, dequeue operation. So enqueue and dequeue operation, people will ask you what is the difference, how will you implement it? So remember this thing, we have to maintain two pointers, front and rear. Rear is pointing to the rear side, the last element, and front is pointing to the first element. So whenever we have to fetch the data, right, so the fetch the data will happen always from the front side. So first in, first out. So let's see, in this particular array I have added 10 first, then I'm adding 15, then I'm adding 5, then 20, then 19, 50, and 66. So whenever I want to, right, so this guy is always in the first queue, right guys? So queue will just like a normal, let's see, there is a queue is there for the movie tickets. So first guy who is in the queue will get the first movie ticket. So first in, first out, first come, first serve. So this guy was added first, so this guy will be out first, then 15, then 5, then 20, then 19, then 50, like this. Okay, so that's why here is, let's see, this is the operation for 66. I'm adding one more guy. So this guy will, this is the queue is going on. This is my queue, right? This is a queue for your movie ticket. And this guy number 66 is coming and okay, end of the queue. So at the rear side. Now the first guy is done. I want to delete this particular data, 10. I want to fetch out this particular data. So 10 will be deleted at the front side, remember. And then what I have to do, I have to shift one index all value rear to front side after deleting the value. So what I'm going to do, my index will be shifted. So this 10 will be deleted, and what will happen? Now this will be my 0, this will be my 1, this is my 2, this is my 3, and so on. So this index will be shifted. The index of 15 will be shifted towards front side, from rear to front side. So remember this thing. Now the 15 is available at the 0th position, first position, second position, third, 4, and 5, and so on. Right? So the moment we delete the data, it will be deleted from the front side and the index will be decreased. And the moment we add the data, index will be increased, but while adding the data, it will be added at the rear side. Remember this thing, it will be behind of the queue. Okay, not at the front of the queue, rear side. Rear means the back side, right? So let's implement these two operations, dequeue and enqueue. How to do that? So this is the exact thing you have to explain at the time of interview. Implement the logic, write a pseudocode, and then write whatever the language that you are using it. So we are using Java for that. So I'm going to create a Java class over here, and let's see, this is my what queue with the array. Okay, queue array implementation. Then click on yes. So what I'm doing is, first of all, that in this particular class, I'm maintaining a couple of class variables. My first class variable, let's see, the what will be the capacity. So I'll be using the size, the capacity of my array. Then I'll be maintaining one integer array because I'm dealing with integer array. You can take any other object array. So let's see, this is my I say queue array. I'll maintain one array over here, and then I'll be using two, as I told you, two pointers. One is front and one is rear. Okay, and then I'll maintain one more important thing, that what exactly the current size is going on of my array, of my queue, right? So these are the different properties I'll be maintaining it. And then I quickly create the constructor of this particular class. So I'll be writing my public, this is my constructor, and in this particular constructor I'll be giving the size of the queue. Let's see, the I simple say that size of queue, one variable I'll be passing, so that I can initialize my array. So I simple initialize my array with this dot queue array is equal to, okay, whatever the, first of all, not the queue array, whatever the capacity that I have defined, this will be my capacity, and is equal to size of queue. I'll be writing like this. Okay, and then initially my front is pointing to where? My front is pointing to 0. Okay, that's the initially, let's see, there are no values, nothing. The front is pointing to 0, right? And my rear is pointing to -1 over here, like this. It's rear, not read, sorry, rear. Rear equal to -1. And then I'll be defining my array. This is my queue array, which is equal to, I'll defining my array. This is my integer value, and what will be the size that you are giving. The size is the whatever the capacity that you have defined over here, like this. So that's why I'll be writing this dot capacity like this. Okay, so whatever the size I'm giving, let's see, 10 array size, the static size, I'll be storing in this particular capacity variable, and then I'm declaring one queue array over here like that. Simple. Okay, now I'll be maintaining two important methods over here, guys. First is I will be checking that, okay, my queue is full or my queue is empty, right? And then I'll be implementing my queue and dequeue over here. So my first method, let's see, I'll be writing public, this will be, it will be return boolean true or false, that is full, and something like this. And then I'll be writing one if over here, that whatever the current size is equal to capacity, then what do you want? You simple return, sorry, you simple return true over here, else you simple write return false, sorry. Okay, so if, see, if current size is equal to capacity, it means my entire stack, I mean my entire queue is completely filled up, whatever the current size, and it's equal to capacity. Okay, perfect. So current size is over here, and capacity that we have given, capacity equal to this, and current size, I'll tell you in some time how exactly we can use current size in queue and dequeue. So this is the first method I'll be creating, and then I'll be creating one more method, that is again boolean return, that is empty, that it's empty or not. So I'll quickly check that quickly. It's simple, that if what, if your current size is equal to 0, simple, then I simple write return true, otherwise return false, sorry, return false. Simple. Empty means your current size equal to 0. It means return true, otherwise false. So these two methods will be giving you true and false over here, a boolean return over here. Okay. Now I'll be creating two important methods over here. One is queue and another one is the dequeue. So how will you implement enqueue and dequeue? So first I'll be creating my enqueue method. So public void first operation is enqueue, queue, enqueue. And for enqueue means what kind of data you want to insert. So let's see, this is my data. This is my data I want to enter, or element, or whatever you can write. And I simply say that, okay, first if condition that if it is full element, let's see, the my queue is already full, then you simply write some system message over here that, okay, hey, that your queue is already full. I simply say that, okay, hey, queue is full, and I simply say that, okay, cannot insert the data over here. Simple. Else, I'll be writing one else over here, that else I'll put first of all that immediately the moment, see, now I'm going to add the data. So what I'm going to do, first I have to shift my rear to the second position from 0 to 1 position, right? Are you getting a point? Because the moment I add, the rear should be point to the second position, right? So first immediately what I'm going to do, my first rear was -1, so I'll immediately shift my rear to rear plus plus, increase the counter with plus plus. Okay, and then I'll put one condition over here that, okay, if my rear, okay, is equal to what, whatever the capacity is going on, okay, the capacity of the size of the queue, when I provided, okay, size of the queue is equal to, let's say, 10, and capacity -1, 10 minus 1, it means, which is, if it is equal to this, then what you do, you make rear equal to 0. I'll tell you in some time why I've written this particular logic. But if it is not true, then you come out of the if part, and whatever the array that you have written, the queue array, and this, and then you provide your rear over here, right? So let's see, rear first time I'm going to insert a data, and this is condition is not true. So rear plus plus, it means -1 plus 1, rear 0. It means for the first position you enter data over here, whatever the data that you are passing, the same data you pass it over here, right? So my first rear was -1 plus 1. So now you got it. Why I have declared with -1, right? So -1 plus 1 is equal to 0, and then simple write 0. You can declare with 0 also. In that case, you don't need to increase it over here. Okay, after this operation, you have to increase it. So better I have written -1, and that's why I have done plus plus over here. -1 plus 1 equal to 0, and data will be inserted at the 0th position. And the moment the 0th position is done, whatever the current size is there, my current size is initially what, nothing. I have not declared my current size anywhere, right? When I'm going to dequeue over here, I'm not declaring anything over here with respect to current size. So my current size also I've not defined over here in my constructor also. So I simple say that, okay, hey, current size increase by 1, right? Increase by 1, and then I'll put in a message over here that, okay, hey, whatever the data that you are passing, plus added to the queue in single double quote, sorry. I'll just append the data like this. Okay, then we will debug it. I'll show you the debugging mode also. So this is my enqueue is ready. So once the enqueue is ready, after that I'll be creating one more method, that is for dequeue. Okay, so I'll just put some comment over here that this method is used to add element in the queue, right? Now I'll be creating another method. My another method is that public void dequeue. Okay, okay, the dequeue method. What exactly dequeue method? Dequeue method is used to what? dequeue method, this method is used to remove the data, remove the element, whatever, or element from the front of the queue. Remember this thing, from the front of the queue, right? Now, what exactly you want to write in this particular method? In this particular method, what I'm going to do that dequeue. So first, quickly I'll check that, okay, before removing the data, I'll check that, okay, my this is empty or not. If it is empty, let's see, there are no element, it means totally empty. In that case, we cannot remove anything, right? I simply say that, okay, hey, as system.out.println, your queue is ready. I simply say that, okay, hey, queue is empty, okay, and I cannot, queue is empty, cannot, I simply print a message, cannot delete element, okay, cannot delete element or dequeue the element, something like this. I can write it over here. But queue is not empty. In that case, come inside the else part, and the moment you come inside the else part, what you have to do first, as I told you, that dequeue means the front side you have to delete it, because this guy is done, we have to delete this guy. So what exactly I'm going to do that, first of all, I have to increase the counter of front by 1, because when I delete this particular data, this pointer front should point to this guy. You can see the next diagram, front is pointing to 15, so I have to increase this front. So initially front was what, the value of front was 0, so I have to increase the value of front now. So I simple write front plus plus, okay, and then I'll putting a condition over here that, okay, if your front is equal to same thing, equal to of capacity minus 1, in that case capacity minus 1, it means I simple going to delete it. So I simple print a message over here that, okay, hey, system dot out println that whatever the queue array is going on, this is my queue array, this is my array. What is my index? The index is simple front minus 1, okay, it will be deleted. I simple say that, okay, removed from the queue, right, it will be removed from the queue. And the moment I remove it, right guys, the moment I remove it, what I'm going to do, I simple write my front back to 0, okay. If it is equal to front equal to capacity minus 1, it means that this entire value is all the values are deleted, and my front is equal to capacity minus 1. In that case, you make front equal to 0, else you come inside the else part, and in the else you simple say that, okay, simple delete this particular data, print that, okay, delete this particular data. And once this is done, what I'm going to do that, okay, once your else part is done, then you have to keep decreasing your size by 1, minus minus also, right, decrease the size by 1 in that case, right. So first you increase the data. If capacity is all the capacity is 0, its front is equal to capacity. Let's see, we have only one element. In that case, remove that element and front equal to 0, it means point the front to 0. But if it is not, then you simple delete it, and current size minus minus, it means decrease, shrink the size by 1 also. So whatever the current size is going on, let's see, this guy is gone, it means the size will be decreased. Initial size was 0 to 6 means 7, now it's 0 to 6. So it was 7 over here, and now it will be 6 over here, right, like this. Now let's test this particular logic, it's working or not, right. So how to test it? So to test, what I'm going to do that, okay, I'm simple writing public static void main, and I'm going to create the object of this particular guy, this class, so that I can call all the methods. And let's see, the method name object obj is equal to this new class name. Over here I'm giving the size is around let's see 5, okay. I want to give, let's see, 5 is the size, okay. So one array will be created with the size of 5, and then what I'm going to do, I simple say that, okay, obj dot, first I'm going to add something enQueue, which data, I'm going to add 10 over here. So what will happen, 10 over here, so 10 will be given to which guy, so 10 will be given to this guy. First of all, that size equal to 5, so constructor will be called, okay, size of queue is 5, capacity is 5. Now front 0, rear minus 1, and one array got created over here like this. So let's do that like this. One array will be created like this. This is 0, 1, 2, 3, so like 0, 1, 2, 3, and 4. So this is my front over here, like this. Right now we don't have any data, and this is my rear over here. Okay, like this. So front equal to 0 and rear equal to -1. Now come back. So what will happen? Data is 10 over here, or whatever data that you are passing, right? I'm passing 10 in my case, right? So data will be given to enqueue method. Is full? No. Is full method will return false, because current size equal to capacity. No, my current size is equal to what? 0 is equal to capacity. Condition is false, so my array is not full. It will come inside the else part and rear plus plus. So the what is the value of rear now? So rear plus plus means rear was 0, rear was -1 initially. So rear plus plus means rear equal to 0. So rear will be 0 now. Okay, and if rear equal to capacity -1, my capacity is what? My capacity is 10. 10 minus 1, 9. Rear equal to 0. 0 equal to 9. No, condition is not true. So it will come inside the outside of the if part, and then rear equal to what? Rear equal to 0, and put the data. What is the data? Data is 10. So 10 will be entered over here, right? And then increase the current size by 1. So my current size, what? My current size was 0 initially, right? So my current size will be 1 now. So that is what is true, that current size equal to 1. The first element got entered. So my logic is working fine with enqueue. Okay. Then like this, let's say I'm going to add one more value over here. Let's say I'm going to add 20 over here. I have added 20 over here, right? So what I'm going to do, that I'll be calling this particular method one more time. So I simply say that, okay, now this time enter 20, right? And then what I'm going to do that, okay, I'm going to obj dot dequeue method I'll be using. Simple. Okay. So I'm going to dequeue over here. Dequeue means remove from the front. So 10 should be removed, right? So I'll be calling this particular dequeue method, and in dequeue method what will happen, right guys? Now see, in dequeue method it will come over here, it will check is empty. No, it's not empty, data is already there, 10 and 20. So is empty will return false. It will come inside the else part, front plus plus. So front was, what is the value of front, right? Front was 0, right? So front equal to 0 initially, front was 0. This condition is not satisfied. 0 is not equal to capacity -1. It will come inside the else part. It's simply saying that, okay, q front -1. It means 1 minus 1, 0 removed from the queue. So 10 will be removed from the queue. And the moment I remove, immediately, whatever the current size was after adding 20, current size was what? 1 plus 1 equal to 2. Current size -1. So current size will be 1 now. Back to 1. It means we have deleted this particular data. The data got deleted, and immediately index will be shifting like this: 0, 1, 2, and 3 now, right? Because current size -1. Now what is the current situation with okay, with front is again pointing to 0, and r is also equal to, rear is equal to pointing to this guy, right? So like this, let's say I'm filling 10, 20, 30, 40, and 50 like this first time, right? Or I'm going to create one more to give you a better understanding, like this. So let's see, this is 0, this is 1, this is 2, this is 3. I'm adding, let's see, 10, then I'm adding 20, then I'm adding 30, then I'm adding 40. So this is my front. Always remember, this is my front of the queue and this is my rear of the queue. If I'm going to add, it will be added over here. Okay, 50. And if I'm going to remove, it will be removed from here. So 10 will be removed from here. And the index, now the front will be pointing to this guy, and the index will be shifted towards like this. Okay, like this. So 20 will be at 0th position, first position, second position, and third position. So whatever the current size, initially current size was 5. Now the current size is 4. Okay, like this it will behave. Same thing in the diagram, exact same thing is written over here, right? So now let's remove this drawing, and let's see. So first I have done what I have done, 10 and 20, and dequeue. Dequeue means the first element 10 that I have added, it will be removed. So let's run it and let's see. So you can see that, okay, data added to the queue, data added to the queue, and then 10 will be removed, right guys? So I'll do one thing, that whatever the data added over here, right? I'll remove this double quote, sorry, my mistake, like this. Now you run it again. So 10 added to the queue, 20 added to the queue, and the moment I remove, it's printing that 10 will be removed, because this is at the front side. So 10 will be removed first in, first out. So 10 first added and first out. Okay, now let's keep adding some more data over here. Okay, now this time adding, let's see some more data, randomly, whatever the data you want to add. Sorry. So 10, 20, 30, let's see, this is my 40, this is my 330. I'm adding some 350 and 254, right? And I'm performing one dequeue operation over here. So now see what will happen. After this dequeue, 10 will be removed. Now who is at the front? 20. And then it will add these four values, and the dequeue will remove what? It will remove 20, because now after removing 10, 20 is available at the front side. So let's run it and let's see. See, 10 added to the queue, 20 added to the queue, then 10 got removed, then 40, 330, 350, okay, and 254 got added, and one second, 250 removed from the queue. One second. Okay, we are doing enQueue, and let me check. It means my dequeue is there is a problem with my dequeue. Let me quickly check the dequeue. Am I missing anything? Is empty. Front plus plus. Front is equal to capacity minus 1, and this is like this. Front equal to 0, else front minus 1, and current size equal to minus this. So this is perfectly fine. Queue array that we are saying that, and removed from the queue, which is also fine, and we are checking is empty, and my is empty method is if your current size equal to 0, then you return true, otherwise return false. Okay, so let's, looks good, not an issue. And let me check my enqueue also. So in enqueue, this is empty, rear plus plus, rear equal to capacity minus 1, rear equal to 0, fine. And array I'm filling with rear equal to data, current size plus plus, and data added to the queue. Okay, so this also looks good. And what exactly we are doing over here, let me check this once again. So we are adding first, okay, 10, 20, we are adding, 10 got removed. The moment the 10 got removed, 20 is available at the front side, and then we are adding 40, 330, 350, 254, and then we are performing dequeue operation. So let's run it again. Okay, let me delete some data, this particular data, or this also I'll be removing it. Okay, so let's see what happens. So 10, 20 added first, and 10 will be removed, and 20 got removed. Okay, in between, let me add one by one some data over here. So I'm writing, let's see, 30 over here, right? And I'll remove this particular dequeue from here, and let's check it again. So first 10 got added, 20 got added, 30 got added, and the 10 got removed. So this is fine. Now what I'm going to do, that after dequeue I'm adding 40 over here, okay, and then I'm adding the dequeue once again. Now let's run it. So first 10, 20, 30, 10 will be removed, right, and 40 added. Now you can see now it's working fine. 20 removed from the queue. I don't know what was the problem initially. So 20 got removed, 20 at the front side, right? Now keep checking this, right? I'll be adding, now this time I'll be adding, let's see, something 550 or 50 or whatever the element that you want to add, and then I'm adding 60. and then again I'm removing this particular queue. Okay, so now let's run it again. Now 30, after removing 10 and 20, 30 is available at the front, and then 30 got removed, right guys? So this is absolutely working fine. Now one more chance, one more tick, we will be adding that. Let's see some other value, 540 and 630 we have added, and then we are going to dequeue. So 10, 20, 30, 10 will be removed, again add 40, 20 will be removed, add 50, 60, 30 will be removed, add 540, 630. So, and again I'm doing a dequeue. So let's see what happens. It should give you 630 got removed. Okay, so okay, now let me add the sequential 70 and 80. The logic is absolutely fine. Let's run it again. In that case, 80 got removed. Okay. Oh, that's the problem. We have given the size as 5. See, my mistake. So we cannot go beyond the size, right? So this is 3 plus 2, 5. The data is already filled, right? So what I have to do, that's my mistake, guys. Sorry for that. I'll be increase the size 10. Okay, because the the queue will be implemented up to 5 only. After that, it will be a normal array. So that's why 80 got removed. Okay, so now let's run it again. Now you can see 40 got removed. Sorry, that was a catch. I really thought, okay, my logic is correct or not, because my logic is absolutely fine. We just need to increase the size of the array. Okay, so are you getting my point? Because initially it was 5, so we were adding only 5 values, 3, 4, 5. After that, it was giving you the wrong data, because after that it was not removing the data from the front side, it was removing the data from the last side, because now it will behave like a normal array in that case. Okay, so now it's absolutely working fine, and let's check one more time. I'm adding some more data over here. Let's see, 750 and 830, and then I'm going to dequeue it again. So last time we have removed 40. Now 50 is available at the front side, and 4 plus 2 6 plus 2 8 plus 2 10. Perfect. So let's run it again. Now you can see 50 got removed, right? The moment you write dequeue once again, then it will give you the false data, the last data, because we are going beyond the size. Now it's saying 60 got removed. Okay, still 0 to 9 we are taking it. Yeah, the counter will start from 0 to 9. Okay, perfect. So better you take some higher range over here, and then keep adding the data and keep checking your code is working fine or not. Okay, sorry for that, guys. It was I just missed that particular. I was given size equal to 4 or 5 only. Okay, but with the large amount of data, you can check with, you just give the size of the queue some large number, 20, 30 or something like this. So it's a little tricky as compared to stack, because here you have to maintain the two counter, one is rear and one is front. But at a time of interview, you have to explain like this, explain this diagram. Remove always from the front side, rear side is always for the adding. So rear side removal concept is called dequeue. Sorry, removal concept is called dequeue from the front side, and adding concept is called enqueue at the rear side. You have to explain like that. So, and the concept is always what? FIFO, first in, first out. Remember this thing. So I'll be writing for you, first in, first out. That is first in, first out. So front is okay, is used to remove the data, and rear is used to add the data. Perfect. That's all for this particular video, guys, and let me know if you have any questions. And thanks for watching this video. Please practice is very important with data structures. Otherwise, today you are practicing, and after 5 days you will start okay forgetting about all these concepts. These concepts are very important for interview point of view, right? So don't panic at a time of interview. Explain, be calm, be cool. If your basics, if your logic is correct, definitely. So I was very much confident, okay, my basic and my logic was absolutely fine. It's all about the data, how exactly you're inserting. Okay, so that's all for this video. Thank you so much for watching, and if you really like this video, please subscribe to my channel, guys. There are a lot of videos are coming with respect to data structure, algorithms, and everything. And then keep learning. Thank you.